A boy runs off a 72-meter high cliff at 4 meters per second. How long does it take for him to reach the ground? How far away from the base of the cliff does he land? And what is his total speed upon impact? So basically they're telling us there's this big cliff and there's a kid, which is crazy probably. He just decides to jump out of it. And he's running completely horizontal, so it's not like jumping and then falling. No, he's just completely horizontal velocity. And he's just going straight at 4 meters per second. Meters per second. The first question is, how long does it take for him to reach the ground? So here, we should see what data we have. And we have S, which is distance, because they tell us it's a 72 meters high. D2. So we've got S, which equals 72. They also tell us a U, but it's not 4. You might think, well, he's high 4 meters per second, but it's not, because we're calculating vertically. So vertically it's 0, U is 0, equals 0. The final velocity V we don't know. Time we're looking for. That's what we're looking for. And then finally we have acceleration A, which equals 10. Well, negative 10, but let's just say 10. So here we have this, and we would use our formula, which would be S equals UT plus 1/2 A T squared. So basically, having this, all we have to do is substitute, put the numbers. So to start, since U is 0, it doesn't matter what T is, it will be 0, so we can eliminate this one. And then we just have to substitute the rest. S, we said, is 72. Which equals 1/2 A, which is 10, so 5, and T squared as our incognita, so T squared. So then we just pass the 5 to the other side, dividing. So let's put that in the computer. So divided by 5 equals 14.4. And then, since we pass the square to the other side, so square root, we'll put that. And that would give us this long number, which we can cut the back out. And so that would be our time. So we put an S in for seconds, and then we put it in a box. So yeah, so it's 3.79 seconds. Next is how far away from the base of the cliff does he land? Well, this one's really easy, really easy. We just have to multiply the time times his initial velocity. And that's it. So we would just do 3.79 times 4. So this is just put it. So 15.16. That would be the distance away from the base. So basically, when he jumps out, that would be how far away does he land. So if he starts falling, well, he will land just at 15.16. Now they ask us, what is his total impact speed? So the impact speed would be, what we'll do is get the, I'll put meters here. Get our speeds, horizontal speeds. So it's we make a triangle of how his way would be, like this. Then we put his horizontal velocity upon impact, and his vertical velocity upon impact, and his horizontal velocity upon impact. So horizontally, it's really easy. It's just 4 meters per second. So let's put 4. And then the vertical one, it's also really easy. We just gotta multiply the acceleration times the time. And since acceleration is 10, it would be 3.79. Now you might be thinking, well, it's not 3.7. Oh no, wait, 37.9. You might say it's not that. It's actually negative 37.9 because it's going downwards. But they ask us for speed, and in speed there's no positive or negative. In velocity there is, but in speed there isn't. So it doesn't have to be negative. And so our answer, even though he's more or less going down, it'll also be positive. So we just have to do a Pythagorean theorem and do 4 squared is 16 plus whatever 37.9 is. 37.9 times equals this. If we add 16, it would be equal to that, and then we just have to do the square root. And that would give us 38.110497241573734. So we just round it up, so that's not so long. And that would give us our answer. And again, positive because it's speed, not velocity. Meters per second. Next, the boy survived his first jump. He now decides to run up a 75-meter high cliff at 13 meters per second. So here it's basically the same thing. So you can pause the video and try to do it yourself. So if you're done doing it, here's how you would do it. Again, we have the same data because it's exactly the same type of exercise. So we use the same formula. S equals UT plus 1/2 AT squared. So with this formula, what we could do is, what we should do is put the values again. So UT is again this exact 0, so we can eliminate this. S is 75, and so this would equal, again they're asking us for time, same question, so plus, well, not plus, we said acceleration was 10, and 1/2 10 is 5, times time squared, we pass the 5 dividing, and so this would equal us 14, 15. So the square root of 15. That would be 3.8729, whatever. Again, we'll round this up. And yeah. So since they ask us for times, we put the unit of seconds. Let's put this in a box. So next is what is his total velocity upon impact, same as before. So we're gonna do this exact same as before too. We put our velocities, triangle, because again this would be him, would have jumped this 72 meter high, and then he just decides to jump again at 75 meter high. So the velocities, we can still do a triangle. So yeah, our vertical one again is just time times 10, so that would be 38.7. and our horizontal one is the same, 13. Well, it's like the same as here, 13. So then we have to do the Pythagorean theorem of those again. Let me just do that really quickly. 13 times 13 equals 38.7. What's the... Oops, not 300. So now we add them, and we do a square root. So square of parentheses plus 169 close parentheses, and it gives us 40 point something. So let's just put that there. And we should round this up, and since there's a 5 here, this 2 becomes a 3. Oops. That's 3. And the total velocity upon impact here. So this is different. Before that stands for speed, now that stands for velocity. So now it is negative 40.83. Negative 40.83 meters per second, and negative because we said it was velocity. So that would be for the total velocity upon impact. Next is a stunt driver wants to drive his car straight up a 4 meter cliff and land on a spot exactly 19.2 meters away. How far does he land on a spot exactly 19.2 meters away? How fast does he have to drive to be driving? So first, let's see our data. Well, this basically would be the exact same thing, just then, well, it would be like this one, which they asked us how away from the base, but instead of giving us the velocity here and asking us how far away from the base does it come, they tell us how far, and then we have to figure out the velocity. So we could, well, what we're going to do is we're going to put our data, which is 4 meter high, 19 points. So first we have to figure out time. So if it's 4 meters high, so this would be S equals UT plus 1/2 a t squared. We can eliminate ut because u is 0. 1/2 a again is 5 t squared, and s would be 4. So 4 divided by 5, that's another one. 4 divided by 5, 0.8, and then the square root. 0.894, whatever. So this would be our time, and with the time, and so how fast does he have to be driving? So now it's very, very easy. We just have to get the distance and divide by the time, because out here we did the time times the speed. We gotta do this the time divided by the distance divided by the time. So 0.9. Well, let's just use the computer. 19.2 divided by 0.89 equals us 21.573. So, well, let's round this up. Let's just get this. Now put that. And since they asked us for velocity, it would be meters per second. Meters per second. But normally, when you look at the speed in your car, you'll see like this circle. Here would be like 0 miles an hour, and I don't know, 200 miles an hour. Well, 200 kilometers an hour, let's just say kilometers. But this, when it goes moving, it would point at kilometers. So this would be in kilometers, not in meters. And so we gotta transform that. And transforming from meters to kilometers, it's not that hard. First, what we do is 21.57 times 3,600, which is basically how many seconds are in an hour, because it's kilometers an hour. And then we divide this by 1,000, because that's how many meters there's in a kilometer. And so the answer would be 77.65, let's take the 2 kilometers an hour. So if kilometers an hour. So you wanna jump out of a cliff and land 19.2 meters away, and you know that the cliff is 4 meters high. You just have to go at 77.65 kilometers an hour. That's it for today, and thank you. Thanks for watching. Don't forget to subscribe and hit that bell.